Hello everyone to all the person are coming today to this webinar. So we will start right now. And thanks for your participation to this new webinar of our software called UrbaWind. And this webinar will be dedicated to our new release, the 3.4 version. And in the agenda presented in the next slide, we will first introduce Methodyne and our CFD technology, just to summarize a quick information about our company. In the second step, we will introduce you our software UrbaWind for the person who doesn't know it yet. On the next topic, we will focus on the new features, and my colleague will present you these topics. Also, we will overlook our improvements, especially for the use of UrbaWind and in the simulation part. And the last one will be our fix, especially on the holes you may have on your CFD simulation. And today, on the next slide, just to summarize who we are, and I let the floor to Guillaume.
Hi, everyone. So myself, Guillaume Cagnot, I'm working at Methodyne since 13 years now as a CFD expert in urban area, and I'm leading also research and development for these projects. I'm a technical project leader for UrbaWind.
Thank you, Guillaume. And I'm Guillaume Vervou. I'm the business manager of the urban product line, and I'm here to help you if you have information about the project or consultancy parts as software delivery. And just a note, don't hesitate to share with the chat or the question tag all the information about your questions you may have to this webinar. And for the introduction to Methodyne, today Methodyne is a company from 20 years ago, created 20 years ago now, and we are dedicated in the wind engineering, climatology, and methodology expertise. And our main focus is to use the computational fluid dynamics to modeling the wind flow and for all complex terrain and structure. And the CFD is a simulation based to take the effect of the environment you may have around your buildings, your simulation area, or your project. And on the next slide, we present three main modules we have in our UrbaWind software. So we incorporate the CFD simulation for three major analyses. The first one will be designed for the pedestrian wind comfort analysis, especially if you are looking to analyze the impact of the wind on the second floor on certain area of your building. The second module will be designed to estimate a proper way of natural ventilation and the potential of natural ventilation around your building. And the third one will be developed to help you to assess the potential wind for urban wind farm, for example. So these are the main three features we have in UrbaWind. And I let Guillaume present you our new features for the latest version, the 3.4.
Thanks, Guillaume, for this introduction of UrbaWind. So I'm very excited about this new version. It's been released very lately, and these are the four main features. So as you probably know, UrbaWind is well known for his expertise to compute CFD in urban area and mostly to assess the wind comfort, external wind comfort. Of course, this is it could be limited as it is only mechanical. So now customers are asking us, what could you do more than that? And there is another one called external thermal comfort. It's a field that exists, let's say, about 15 years ago, and there are nowadays more than 200 indicators about thermal comfort. And there is one that is quite popular nowadays. It's called UTCI. It exists, well, say since 10 years ago, 20 years ago, sorry. So this is the one we're going to explain in the next slide. But so far, we're going to focus on this. This is the biggest feature, computation of UTCI. The other parts are dedicated mostly to use UrbaWind in a more international way. So there are more norms, more / recommendation depending on the countries. You can display wind speed not only as SE units, but another British way. And it's possible to compute another way of gust. That this is a big update from the previous version. So let's have a look on the biggest feature, the computation of UTCI. So UTCI, for those who are not familiar, names for Universal Thermal Climate Index. So the idea is that it's valid in all climates, in all season, in whatever the scale from a house to a city. So it's not limited as geographical projects. It's also independent of the, let's say, of the age of the persons, of the gender and how it is close. That's why it's called universal. And the scale has been designed to be recognized as a thermal, so it's in Celsius. So how is it working? Basically, what you need is climate information, of course. So what we are using is air temperature, humidity rates, irradiance, and these are coming from the weather data. The most famous one is EPW for energy plus weather data. And what's left is the mean speed. So good news, you can do it with UrbaWind. So you export your project, your synthesis, and you export your map of wind speed. And we're going to use the plugin. There is a plugin that has been developed using Grasshopper. So Grasshopper using SolarCal, sorry, can compute the last parameter, which is tricky. It's called radiant temperature. It's whenever you are close to a wall, you have a radiation, thermal radiation coming to you, and so it depends of the building shape, of the properties of the environment, if it's mineral, and so on. So this is the thing that Grasshopper can compute, and you merge all that information, and you are able to compute statistics about UTCI. So here, an example of what can be done are mappings of UTCI. You can compute the mean part, so the mean over time period, and you get out as an output, you get a range of thermal stress with different stress, thermal stress. So this is one possibility. The other statistic information are on the next slide, and there are three. So you can define how much time I'm going to overreach a criteria defined as hot, which is 26 degrees. So it's UTCI frank hot. On the opposite, it's when it's becoming cold. So it's defined as 11 degrees, and this is on the right side. And the middle one is neutral condition, which is in a good condition. So the main assumption of this computation is that you are working with concrete in your computation, since you want to evaluate what will be the worst scenario. And everything is done using rhinoceros, grasshopper. Yes, you can go on the next slide. So this is a paper that we are that I wrote for last building simulation. I've made a comparison in Port Said in Egypt during the summertime. Basically, it was a street canyon with props inside in June, and we compare the evolution within a day. It record all the variables I mentioned earlier, and I compare the outputs of UrbaWind Grasshopper to what is done with EnviMet, the other reference regarding thermal comfort. And you have on the table, you have the four props. What we can see at the end is that we get the same order of error as EnviMet, about 10 degrees difference in maximum. So the computation is looking good, and all you need is to import a plugin in Grasshopper, drag and drop, and call the variables, the four variables depending of the statistics you are looking at. It's as simple as that. So let's carry on. The next feature, as I say, is to become more and more international. So we integrate more norms, recommendation regarding wind comforts. So you can work now in British countries, ex-British countries such as Australia or Canada. We have also had criteria for US. And customer in those countries were asking me if we could integrate their units for wind speed. So we have now divided 3 units, nodes, kilometer per hour, and miles per hour. So you can do it on the fly in the interface. And the last one also ask from Canada, let's say. So they are using the gust equivalent mean speed with the frequency threshold. So we are mostly used to work with criteria of gust speed, but in Canada they are using the opposite way, frequency threshold. So it's possible and it's straightforward. So let's have a look on the improvement. So this will save you some times. There is one basically when you are running a case, you have, for example, balconies, and you want to have a look on multiple surface, and you define the first surface and you want to look at the other surface. So you have a button to duplicate the surface. You just have to modify the new altitude or height, and it's much faster than before to define surface or to define your case. And as you know, the project is mostly human time, so it's where you can save a lot of time. The second improvement was made mainly for the support, let's say. There are options saved when you are launching CFD, and there were two options that were not be saved before, which are turbulence and convergence model. So just a brief recap for those who forget or didn't know that we have two turbulence model. There is one from the 2015, and it's much more accurate. And this one is by default. And the other one, it's another convergence model. It's called high convergence model, and it gives you better results and much faster results. But it's not by default. The reason is that in 1% of the case, it will take you more time to compute. So this is why we have decided to switch the default one to the other one. So you have this possibility to tune that the convergence model. Those two are in option. And the last one, we have integrated for years, and it's one of the difference with the competitors. We have integrated a database. This database is could be at the city scale or region scale, and it's very nice, but it can be sometimes you have to be careful of that data. Is whenever you have local topography that can change the wind flow around your project, and this is not integrated in the database because we compute the average over the city or the average over a region. So we warn you if whenever you are using this database, and if you are not sure if it's good enough, this database for your case, you can send us an email, and we will answer to you. So these are the three improvements. The next one, it's a fix, but it's quite important fix. This is an example of a picture of you could add in the past in version 3.3 on the left image. You can see you have some dots on the surface of wind speed. You have a lot of spots, and it means that we are missing points. So this is not nice. And you could also have different missing data for each direction, and they will be different at different location. And when you mix all that in the synthesis, it will add all the missing points for all the direction. So this kind of I call that speckled image. So it's not very nice, and you could also have a look. You have a line in the lower parts of the image, and this also was missing data. So this now is solved. You are on the right side. You don't have any more missing data. It's been resolved. So this is a quite it's a fix, but it's important fixed. So I think we are finished with the presentation. Now it's time for you to ask question about. I will be very happy to answer to your question. So let's have a look. We have a question regarding UTCI. So there are more practical classification of the categories, more similar to wind comfort classification. This is the only classification we have. At the end, as I say, you have classification depending of the stress. So as I don't remember, but there are more than 10 classes of stress. So it's quite details, and we have summarized them with frequency. So whenever it's neutral or like in good condition, thermal condition, or whenever it's hot or cold. So it's specified.
So there is a question, is this update included in all packages? Yes, of course. So as main, if you are downloading the latest version of 3.4, it will be available for all modules, but not for the 3.3 version you may have by the past. So you can have the latest version, but it will not include the TCI in the previous version before the 3.3. I think there is another questions for you, Guillaume.
Yeah, yes, exact. Yes, didn't mention that, but on the workflow to compute the UTCI, it is request to to get to have a Rhino license, since we need the model in Rhino.
And I think, Guillaume, there is one
A
last
question,
question.
but it's more related to the other previous version. So there are questions about turbulence and convergence model. Yes, I can repeat what I said. So that's quite important. We have two convergence model, and there is one from the 2015. There is a paper about that, an article. It's on the web page. You can have a look. So the last one is much more accurate for mostly for the wind pressure around the building, so nearby the buildings. And this one is by default, and the other option is a turbulence model. The turbulence model. So as I said, there are two. There is a new one from the version 3, and it's much faster, much more accurate in 99% of the case. But since there is this drawback on over 1% of the case, it is not by default. So you can activate by default this one in the option configuration. And those parameters now are saved in the properties of UrbaWind.
There is one question about the tutorial for the new features. Of course, we have a demo set to present our new features and this UTCI module incorporation, so we can share it with you on demand. So don't forget to send us an email about it to know more about the use and how to use it properly. And also the new version will be available right now since the new release. So don't hesitate to communicate with us if you want it to be integrated in your actual version. And we can look in deeper details to install it and to share it with you, the new improvement. And I think for the questions, it's mainly all. Maybe a last one.
Yeah, there is a last one regarding the the time zone and latitude. It is basically when you import your EPW. So you have the time zone and latitude inside this EPW. So and all the data for air temperature and irradiance are inside, so you don't have to do anything. Just import your EPW. You have all your weather data inside and the right time zone.
So thank you, Guillaume, and thank you
Thanks,
all for your
everyone.
petition.
Very happy to be
And
here today.
it was quite interesting to share with you our new improvements and features. And we stay connected with you if you have other questions.
Thanks, and have a good
So
day. to everyone.
Thank you and have a good day. Bye.